Day 3. We're going to focus on continuing how to graph quadratic functions. We're going to identify if the graph opens up or down, so it has a maximum or minimum point, the y-intercept on the y-axis, and then we're going to graph the parabolas. All right, first slide. This is an important example for you to write down. We're going to focus on first finding the y-intercept. How you find the y-intercept, there's a few different ways to do it. Here's one way, is if you have an equation, you substitute 0 in for x. Step 2, simplify and solve for y, and then write it as an ordered pair. So we have an example to go with it on this slide. All right. This example is a quadratic equation in factored form, and we want to find out what is the y-intercept. So we're going to substitute 0 in for x. That's step 1. So we have a 0 replacing the first x. We have a 0 replacing the second x. And then we simplify. So 0 minus 3 is negative 3. 2 times 0 is 0. And then we'll go and add 0 plus 5, which is 5. And I'll multiply those two numbers together. Negative 3 times 5 is negative 15. Step 3 is to now write that as an ordered pair. So imagine your coordinate plane. This is your x-axis and this is your y-axis. That ordered pair is going to be down 15 units on the y-axis. What that ordered pair then is over 0, down negative 15. So writing it as an ordered pair, it's 0 and then negative 15. Here's another example. I would say you don't need to write this example down. It's going to follow the same steps. So I'd like you just to follow along. This equation is now in vertex form. So we want to do the same thing. We want to substitute 0 in for x. So 0 plus 5, all squared, minus 6. Simplify that parentheses, 0 plus 5 is 5. Then 5 times 5 is 25, minus 6 gives us 19. So then our ordered pair for this y-intercept is over 0, up 19. Third example. This one I do want you to write down. I'm going to teach you how to do this problem two ways. The longer way and the shorter way. This is what we call now an equation in standard form. So we're going to go ahead and do the method we've done the last two examples. We're going to substitute 0 in for x. So then 0 times 0 is 0. 2 times 0 is 0. Negative 5 times 0 is 0. And we're left with negative 6. So our answer then would be over 0 down negative 6. A little trick we like to use here at our school is if it's in standard form, the y-intercept is going to be the c of the equation, so the constant. So if I look right away at this equation in the red, the c is negative 6. So we wouldn't have to go through all those black steps of substituting 0 in for x. We could just identify the ordered pair as over 0 down 6. So that's the second way to do it. And that only works when the equation is in standard form. All right, we're going to move away now from the y-intercept and focus on what happens when you have the a. I'd say you don't need to write this slide down. So here's a function, a quadratic, and we're going to focus on what does this a do to our parabola. If our a is a positive, the parabola is going to open up. So the shape will look like this. If the a is a negative, the shape is going to open down. Parabola will look like that. If my a is less than negative 1 or greater than 1, the graph is going to look what we call thinner. It's going to be skinny. It's really tight, depending if it opens up or down. If my number for my a is a fraction or a decimal between negative 1 and 1, the parabola is going to look wider. Here's how it looks if it opens up or if it opens down. The a decides how close your parabola is to your x-axis. All right, so we're going to look at the parent function first on the bottom of this slide, and then notice the difference between the two equations. So here's our parent function, y equals x squared. To review how we graph the parent function, we have an xy chart. We substitute values in for x. So we start with 0. 0 times 0 is 0. So this is what we call our critical point. That's also the vertex. Now we substitute 1 in for x. 1 times 1 is 1. So over 1, up 1. Now we substitute negative 1 in. Negative 1 times negative 1 is 1. So there's our third point. Let's do 2 more. 2 times 2 is 4. And then negative 2 times negative 2 is 4. And then we'll graph our parent function. That's before any transformations have occurred. Notice where the vertex is. The vertex, which we call our critical point, is at 0, 0. The axis of symmetry that cuts that graph in half is at x equals 0. This parabola opens up. All right, let's go up and graph these two equations. First equation, y equals negative 6 x squared. There's actually two transformations that are going on. The first thing is the negative. The negative tells me that it opens down. The 6 tells me that my graph is going to stretch on the vertical axis by 6. So if I think about my original parent function, again, I'll just quickly graph that so you can see the difference. What's going to happen is I'm going to reflect above the x-axis. So So now my graph will look like this with the reflection. But then I have to stretch it by 6. So now my critical point still is my vertex, 0, 0. But I'm going to stretch these points on the y-axis. So if I think about these 2 points, where they're going to be, right now they're at 1 and -1, and -1, -1. They're going to stretch on the y values by 6. So 2, 4, 6. So this point is really going to go down here (1, -6). And then that other point is going to stretch down 6 units on the y-axis to -1, -6. So the final graph is in the black of this picture. Last example for this lesson, we have an equation where we're just changing the scale factor again, and we're going to multiply it by 1/2. So I'll graph that parent function again so you can see the difference. And this parabola is going to open up because it is a positive a. There's a positive in front of here. I don't have to worry about any reflections because it is opening up. Now, we had those same critical points, 0, 0, and then we have point 1, 1, and -1, 1. What happens again is we are going to stretch, multiply that y value by 1/2. So if I think about my y value, it's going to change to 1/2. So I'm going to go 0, 0, and then over 1, and then up 1/2. And the other one is going to be -1, up 1/2. Notice how much wider the parabola is. Here is your assignment for 5.2, day 3. Page 323, 5 through 7, 15 through 20. Again, ignore the directions. Now you're going to graph those parabolas that you're introduced to yesterday's assignment. You'll identify if the graph opens up or down, and you'll find the y-intercept.